Hi y'all. In this video we're going to use an Excel sheet and an example to discuss how compound interest works. In this sheet I've kind of typed some stuff up and you can see that we're starting with an initial amount P of $1,000. We're dealing with an interest rate of 12% or 0.12. The number of times we're compounding each year in this example is 12 over the course of 2 years. And what that's going to equate to, compounding 12 times a year for 2 years or compounding monthly for 2 years, is a total of 24 months, 24 time periods. What the situation here is kind of talking about, or one way to look at it, is to say that we started with an initial amount of $1,000 in the bank. And one very important aspect of compound interest that we'll need to understand as we make this little Excel sheet is that during any time period described, the interest is going to work like simple interest. And what's going on here is we started with $1,000 in the bank. That's our very initial amount in the first time period. And it's growing at a rate of 12% over the course of that first month. So that's just the normal simple interest. So this is going to be P. I'm going to set it up so that this whole sheet will calculate automatically what I want it to. P times R. R is up there. I want to use an absolute reference. Times time. Now we want to be a little careful with time. When I'm saying it's simple interest for any one time period, I need to pay attention to the fact that the time period here is 1 month. And time for simple interest needs to be measured in years, so I need to recognize the 1 month as 1/12 of a year. Now for the values I've used, this should really be 1 over 12, that is 1 over the value I'm saying n is. And in general, that's going to be the case. I'm going to use an absolute reference again here. But in general, again, the time period for simple interest will be 1 over whatever n is during any one time period. And it doesn't need it here, but I'm going to set this up so that it will round this interest amount to 2 decimal places. Okay, so during that first month, what's going on in this problem, that $1,000 would have increased by a total of $10, and our ending amount would have been the sum of those two things. There's just 2 of them, and there's only ever going to be 2 of them. I can just add those up. Well, our initial amount in the second month will be our ending amount for the first month. This is how compound interest works. And now that interest calculation will be based on this new initial amount. You'll notice here that the interest earned in the second time period will be slightly more than the interest earned in the first time period. And that's what goes on with compound interest, is that you earn interest based on the new amount, and it'll increase as we look at each of these interest amounts. So now I've got the second line how I want it. If I copy and paste this, Control C and then Control V all the way down, we can see what goes on in each time period over the course of this problem. And again, if you look in the interest column, you see those amounts increase as you go down the value, and you get to a total amount of $1,269.74. Briefly, if I typed this in with the normal compound interest formula, that is P times 1 plus R divided by N raised to the N times T, you get a very similar number. And it's off by a few pennies, and that frequently will be the case, but we're typically going to think of the 1269.70 as good enough. Hope that helps you to have a little better understanding of compound interest, and we'll go from there.